Jasmine has 64 roses and 36 sunflowers she will use to decorate tables. She wants to have the same combination of roses on each table and the same number of flowers on each table. What's the maximum number of tables she can decorate if she used all of the flowers? Now, this word problem was nice, and it used the same keyword we just had, which was maximum. So we know we will be finding the greatest common factor of 64 and 36. Now, I added an extra ladder rung because I did this one by myself, and we may need an extra step. So I'm going to start off with 2 because 64 and 36 are both even numbers. If you already want to look at it and you know what the factor is, that is great. Or if you already want to go ahead and set up the table, you can do that too. I just know myself and a lot of my friends on here probably don't know all of the facts of 64 and 36. So I'm trying to do the process of elimination and just start off with 2. You can do whatever works best for you as long as you still get the same answer as I do, okay? That's the one thing I love about math is there's different ways to solve a problem, but there's still only gonna be one answer. So it doesn't matter if you solve a problem or you find the greatest common factor by using 2, or it doesn't matter if you already know what the greatest common factor is. As long as we get the same answer, everything's fine, okay? So, off my soapbox, back to teaching. 64 and 36, I'm gonna divide both by 2. So now, I don't know at the top of my head what both of these numbers are divided by 2, I'm gonna be honest. So over here on this side, I'm going to divide 64 divided by 2, so I can figure out what's gonna go in this next ladder run. So I know 2 can go into 6 3 times. 3 times 2 is 6. Subtract. 6 minus 6 is 0. Bring down that 4. 2 can go into 4 2 times. 2 times 2 is 4. 4 minus 4 is 0. So 32 is going to go right here. And we'll do the same thing for 36. So we have 36 divided by 2. 2 can go into 3 once. 1 times 2 is 2. 3 minus 2 is 1. I think I already did this problem up there. 6, bring it down. 2 can go into 16 8 times. 8 times 2 is 16. 16 minus 16 is 0. So 36 divided by 2 is 18. I'm going to write that right there. I'm going to erase this. All right, so now I have 32 and 18. I can divide by 2 again, or because these are a little bit smaller numbers and I think I know the facts to both of these, I'm going to do a fact table on the side. So do 32, 18. Let's write all of the factors of 32. I'm going to be easy. I'm going to do 1 and 32. Because why not? Another one that the most of us really know very well is 4 and 8. And then one factor set that some people may not know at the top of their head, I don't expect y'all to know at the top of your head right now, would be 2 and 16. So these are the factors of 32. Again, the ones that y'all probably will know for sure would be 1 and 32 and 4 and 8, which is completely fine. So now let's find the factors of 18. We have 1 and 18, 2 and 9. And then 3 and 6. Is there anything else? No, I don't think so. Okay. So now we're going to go in, and actually it would have worked regardless. We're going to go and circle the factors that they have in common, which is 2. So we're going to use 2 again. So we're going to do 32 divided by 2, which is over here. I said 16. I think I did this wrong. Pause. No, I did it right. Okay, sorry. Just fun fact, teachers, we tend to mess up sometimes. So it's okay. People make mistakes. I make mistakes. So if you make a mistake, it's okay. Because I just made one. Well, I thought I made one. And then I corrected myself because I really didn't make one. All right, back to the lesson. So 18 divided by 2 is 9. Now, looking at 16 and 9, I don't think they have any factors in common, but I'm going to do another factor table just to double check, because there's no harm in double checking. If anything, it will help you rather than hurt you. So remember that. If you feel like, I don't want to like double check, I don't want to do all the extra steps, I promise doing the extra steps will help you before it hurts you. Okay? Remember that. So now let me write out the factors of 16. We have 1. 16. What else? I heard someone say it. 2. 8. What's another one? Yep, I heard someone say that too. 4. This will be 4 times 4. All right, let's do 9. So I have 1 and 9. And then what can I multiply together to give me 9, y'all? If you said it 3, that is correct. 3 times 3 gives me 9. Y'all so smart. So now looking at this lovely table, are there any factors that they have in common besides the number 1? I don't see any, so no. So 16 and 9 don't have any other factors in common besides number 1. So I need to find the GCF, because I'm done now. I'm done factoring. I just gotta find my GCF. So when I do that, I'm gonna multiply 2 times 2, which gives me 4. Now remember, I'm writing it down over here, but I want y'all to put your statement here. If you're typing, it may move it down to the next page, and that's okay. But if you're writing this down, you can just write it in this general vicinity. So my statement is going to say, I'm going to reread the question. It says, what's the maximum number of tables she can decorate? So we're going to say the maximum number of tables is 4. And that is our answer.